The next point is going to be uh, the next point is going to be something which is called as physical properties of substances. What the physical properties of ionic substances are, it's like how they are going to be physical, obviously. So the first property is going to be like their melting point. So things are going to be in a way that ionic compounds are having higher melting and boiling point. So you have to provide them an excessive boiling or melting point to break the attractive forces present between them. So definitely they are having higher melting and boiling point. So simply you have to provide them with an excessive temperature to break what? To break the strong electrostatic force of attraction between them, and we have to supply energy from the outermost environment or from the atmosphere to break the bonding. Now, why we have to do this? Because they're having oppositely charged group, and it is quite natural that oppositely charged substances are going to attract each other with the greater forces. And in order to break this force, we have to provide them with excessive amount of energy. So in the simplest way, if I write up the NaCl over there, Na would be positively charged and chlorine would be having negatively charged onto it. Chlorine is accepting electrons from the sodium. Now this attraction will be quite huge. In order to break this one bond, I have to provide them with excessive amount of energy. There you can see this crystalline nature. So in order to break this bond, we have to apply with the excessive amount of energy onto them. Next thing would be ionic compounds tends to be crystalline. What is it? Simply this reflects an idea that this reflects the regular arrangement of ions in a lattice. So this is going to make a reflection onto the regular arrangement of ions in the lattice. So in order to make this reflection possible or regular arrangement possible, we just allot them with the term crystalline. So just like the way we have used the term earlier that what is it? The lattice. Okay. So crystal lattice. Yeah, sorry. So that was having the regular arrangement or the pattern. So it comes when it comes to the regular arrangement of the pattern, this is going to be found by the crystalline. Sometimes the crystal are too small to be seen with the naked eye. Can't see or identify them. We have microscope to make them look bigger. Now, magnesium oxide, for example, it is always seen as a white powder. Magnesium oxide is always to be it seems like a white colored powder. So, because its individual crystals are too small to be seen with the naked eyes, but simply in a collective order, in a collective manner or pattern, when they collaborate or arrange with each other, they are going to give rise to some white color to the entire structure. Next thing is going to be the third property would be brittleness. What the brittleness is, it's like how certain layers of positive and negative charge groups are arranged. Just like in a way, this is negative group and a positive charge group, they are attracting each other. So generally we used to say that things or atoms are arranged in a proper position. Why? Because they are stable structures. So now you can see that positive and negative are holding each other in this way and positive and negative are holding each other in this way. So at this time they are stable. So they could be brittle. What is it? Because they, upon any small distortion, this arrangement will bring this negatively charged group close to a negatively charged group, just like in a way. Upon doing this thing, this will cause repulsion in the entire structure, and what it will cause, it will break down at this thing. So you should be clear. Normally, positive and negative charges are oppositely arranged, just like we have seen the case of sodium chloride, let us. But upon facing certain pressure or condition, they are going to face attraction between negative and negatively charged groups and positively charged groups. Now, in that case, they will be repelling each other. Upon this repulsion, they will have to suffer from brittleness. They are going to break the like a proper structure what they are having onto them. Now, ionic substances tends to be soluble in water. Now, why they are soluble? Because simply, if I again place water there, let's say this is a water molecule having negative charge on oxygen, positive charge on this proton. right there. Now they're holding each other. So they, let's say I dissolve salt, a common table salt in water, which is generally called as NaCl. Oxygen will be attracted by sodium, or sodium will be attracted by like oxygen, the better word. Now chlorine is electronegative. It will be attracting hydrogen. Upon doing this activity in a positive way, what will happen? They are going to attract each other, and this positive and negative charge attraction will lead towards the lead towards an activity which is called as the solubility of the compound. When it comes to like ionic compounds tends to be insoluble in organic compounds, whereas it is simply like they tends to be insoluble in the organic compound. Generally, organic solvents include carbon. So, what comes to the difference in the type of bonding? Ionic bonding is simply transformation of electron. What major type of bonding is present in the ionic compound is the covalent bonding. So that could be although polar, that will have charges on it, but it is simply they are not feasible to got soluble in each other. Extensive work includes the concept of polarity. What a polarity is simply when two opposite charges attract each other, when opposite charges attract each other, this is going to make things look like polar, and this is called as polarity. Simply, water when got soluble in like sodium chloride, they are that solubility happening. Why? Because they are polar. And when it comes to magnesium oxide, it is not really soluble in water, although both of them are polar. But the attraction between water molecules and the ions are they are not strong enough to break the pre-created bond. So simply we can say that the attraction is not bigger enough to break the bonding that was previously present in water and so and magnesium oxide if the electroforces of attraction were strong. So simply, hydrogen could have attracted oxygen, which was attached to magnesium, and they could exchange the bonding. So definitely, the exchange of bonding of atoms is not possible due to the weakness of electrostatic forces of attraction. Next thing is hexane. Hexane is a non-polar structure. It does not create any strong forces of attraction to the ions because they are going to break the ionic lattice base with. Now, molten thing just means that salt has been melted. It is converted into a liquid form. Last point would be about this like moltenness or conductivity. Ionic compounds are really not conductor of electricity when they are present in the solid, so in the solid form. So you should be clear that conductivity is only possible whenever free movement of electron is provided. If something is not moving freely, it is not going to conduct any electricity. So when we use the salt that is placed in our home, they might be on our table or something, they are the non-conductors. Why? Because there is nothing, no free movement of electrons is there. But if we melt them off, then they are going to conduct electricity. Why? Because in that case, we are providing them with the free movement of electrons. So definitely liquid salts are when salts are in their molten form or in their liquid form, then they are going to conduct the electricity. Otherwise, in their solid form, no free movement of electron is observed. That is why they are not going to conduct any electricity. So that's it for